All right, so now that you understand what the electric force is, the next thing is to talk about the electric field. So the electric field is going to be given by a cursive E, and then its official metric unit is going to be called the Newton per Coulomb, but you don't need to know that. Okay, so this one you definitely need to know, this one you need to know, this one, and of course you need to know all of these different letters here, but you're not going to need to know that particular unit for the exam. So you should know what causes an electric field, and you should know how to draw the electric field. And remember that you're going to use a teeny tiny positive charge in order to do it. So that if you have a negative charge and you want to know what's the electric field that's going to surround that negative charge, remember to use a teeny tiny positive charge to test for it, and you just observe which direction is that charge going to be pulled in. So in this case it's going to be pulled down, but if you were to put that charge down here, it's going to be pulled up. And so in the picture there, it kind of looks like spokes on a wheel, but remember that it's three-dimensional, so that those spokes are also coming towards you and they're going away from you. So it's in a more like 3 dimensions, kind of like a pin cushion. And then you should also know what the electric field looks like for a dipole. So that's going to be a negative and then a positive, so having 2 poles to it. And so again, if you take a positive charge and you put it over here, it would be pushed away and then pushed away and then pushed away. And now all we've got to do is connect it in between. And so to do that, we take our teeny tiny positive charge, we put it in there, and notice that it's going to be attracted this way and repelled this way, so we need to have an arrow going like that. And then we can connect these lines kind of like this, and then that would be the electric field of a dipole. And the only reason why I want you to know what it looks like is it really has the same shape as the magnetic field of a bar magnet, where you have the north pole and the south pole of a bar magnet. You find that it makes a very similar looking picture to it. Okay, then the next thing that you need to know is how is the electric force related to the electric field. So you'll see that there at the bottom is a formula that has a red box around it, and so you can see that it says that the force of electricity is going to be equal to the charge and then the electric field. So you're going to be given the electric field. You then take a charge and you put it into the electric field, and then if you multiply those two numbers together, that tells you what the force is that is acting on it. And notice that the direction of the field is the same as the direction of the force. So whichever direction the electric field is going in, if you take a positive test charge and you place it in that field, the force will be in the same direction as the field. Now if you've got a negative charge, it goes in the opposite direction. Remember, everything is based on positive charges. So if you use a negative charge, then it goes in the opposite direction. And so there's a formula that you should know for the exam. And so here is a sample question where you would be using that formula. Okay, then you should know what a capacitor is. So a capacitor is going to be 2 parallel plates, and then when you attach it to a battery, negative charge appears on one plate, positive charge appears on the other plate. In between the plates is going to be the electric field, and we could say a capacitor stores what? electric charge, electric field, and electrical energy. So that's what a capacitor does. And then once it's charged up, you can disconnect the battery, and for quite some time that capacitor will remain charged. And then if you attach the capacitor to some electrical circuit, those electrical charges then can flow through the wire and it can do something. Well, here's another formula. So this is going to relate the voltage, and another name for voltage is the electric potential, to energy. So now we need to add a couple of more things here. So voltage is going to be given by a cursive V, and it's going to be in volts. And then energy is going to be given by a regular E, because this one was a cursive E, and then this is going to be in joules. So that the energy of an electrical system is going to be related to the voltage of the electrical system. So that if you've got a voltage and then you've got a charge that you put into that voltage, it will have a certain amount of energy given by that formula. So now we can put over here that voltage V is going to be equal to energy E, and then divided by charge Q. And then if you want an example of how to use this formula, there you go. So again, I'll give you all of this on the exam, but you've got to know what the letters mean, and you need to know how to put the numbers into it. Okay, let's take a break, and when we come back, let's talk about electrical materials.